Hi everyone, I want to welcome to the first episode of the initiative of Royal Statistical Society Nigeria Local Group titled Effective Use of Statistics in Making Informed Decisions. My name is Oyeyemi, Professor of Statistics from the Department of Statistics, College of Physical Sciences, Federal University of Agriculture, Abeokuta, Nigeria. Our speaker for today is Professor Gafar Matami Oyeyemi, Professor of Statistics from the Department of Statistics, University of Unilorin, Nigeria. The title of his presentation is Uncovering the Hidden Patterns. I'm sure that you will enjoy his presentation. Thank you.
Good morning, good afternoon, good evening. I'm Professor Gafar Matami Oyeyemi, Department of Statistics, University of Ilorin. The title of my presentation is Uncovering Hidden Patterns, the Importance of Statistical Analysis. When we talk of hidden pattern, definitely we need to have the mindset that we are talking about data that are so big. We may use the word complex data or big data so that we have many variables. The variable may be in hundreds, thousands, and the number of observations as well is so many. In fact, in most cases, the number of variables are likely to be even be more than the number of observations. When we talk of micro array of data and genomic data and so on. So when dealing with such vast amount of data, or what we call complex data, so the researcher often find themselves in need of some tools that can be used to uncover the hidden patterns, themes, similarities, even trends that may be inherent in such data. And this is where the statistical tools, such as factor analysis, cluster analysis, discriminant analysis, among others, come into play. We call them multivariate techniques. So this presentation will dwell on just two of them, and they are factor analysis and cluster analysis. They are both powerful techniques of statistics that are normally used in uncovering hidden patterns in complex data. Cluster analysis and factor analysis. Most researchers, especially the non-statistician, they do confuse cluster analysis with factor analysis, whereas the two are not the same. Clustering is grouping or collection of data points in such a way that members or individuals in a particular group or in the same group are very similar to one another, and they will be quite different from members belonging or in other groups. That is how or what factor and clustering analysis does. That is what we refer to as clustering. Whereas in factor analysis, this can be likened to a detective tool for researcher. It helps in simplifying complex data by grouping similar variables together. The variables that are correlated, that are highly related, are being grouped together. So it aims at uncovering hidden factors that influence the measured variables. So it helps us in looking at, okay, this group of variables are actually, measured variables are actually talking about this hidden, or what we call latent variable. So this on display is a diagram of factor analysis. The yellow rectangular boxes are the items or the variables that we measured, while the blue circles or bars refer the factors that were extracted from those items, those measured variables. As you can see, the variables, maybe 2, 3, are being grouped together, so to form a factor. In some instances, you may have as many as 8 variables being grouped together to constitute a factor, so that each of these factors could be interpreted to be measuring a particular hidden variable or hidden factor that we cannot measure directly, Now, on display is a cluster analysis output. On the horizontal axis are a number of countries, about 40 of them, that are being clustered into groups. As you can see, the cluster will start by grouping two individuals, referring here to as countries, together to form groups, to form clusters. And it will continue to be reducing the cluster, maybe into from 6 to 5 cluster, 5 cluster to 4 cluster, 3 cluster, 2 clusters, and so on. That is how cluster analysis, how it works. So it's going to group individuals or objects into groups based on the measured characteristics. Now let's look at the difference between the two techniques. For any given complex data, cluster analysis will always obtain possible grouping or groups of individual objects based on some similarity functions. But factor analysis will uncover underlying or hidden factors or patterns by grouping variables into different groups known as factors. Call it constructs, and this construct is known as factors. They are both techniques in simplifying complex data in order to have a better understanding and a good interpretation of complex data. So a better understanding by uncovering some hidden patterns that may be exhibited or inherent in a given complex data. So that's what they both do. Look at the similarity. So they are both powerful techniques for researchers seeking to uncover hidden patterns and or themes or structure that may be within that complex data. So they simplify complex data in such a way that they are going to provide insights, though they do not provide a definitive answers, but they act as a magnifying lens in revealing patterns, uncovering patterns in the data. And this will definitely guide the researchers in further analysis or investigation. Let's look at exploratory and confirmatory analysis. We have both confirmatory or exploratory for both cluster and factor analysis. And when we talk of exploratory analysis, we are referring to a situation in which researchers are unsure of what they are looking for. They are just exploring. So in such a way that they will explore the data and look at, okay, can we have 3 cluster, 4 cluster? In the case of factor analysis, is it going to be 2 factors or 10 factors or 3 factors that may be meaningful or give better interpretation? Going further, so the researcher is not likely to know or may not know the number of factors that he or she may be looking for or that are even inherent in the data. But we keep on exploring until he or she arrives at an ideal number of groups or cluster in case of cluster analysis, or ideal number of factors in case of factor analysis. But for confirmatory analysis, this is employed when the researcher already have a hypothesis about the number of clusters or the number of factors that he or she is looking for. So before the analysis, he already knows that, okay, there's going to be 3 groups, there's going to be 4 groups. Or in case of factor analysis, he already knows that he's going to be having 4 factors. So he had this, so he just want to test the theory using the information or the data collected. So that is a confirmatory factor analysis or cluster analysis. So I'm giving us some 1 or 2 examples of cluster analysis. So the first one is about research on certain diseases. So if a researcher collects information on environmental and genetic factors of individuals, so this information can help the researcher in clustering the individuals into groups in order to make a progress towards understanding that, okay, who is more likely to have this certain disease, who is more likely to have this other disease, and so on. And this will help the researcher engaging how much individuals may be at a risk for a particular disease. Another example is about movie streaming analysis that collects information or data on viewers on Netflix or YouTube. This information collected on customers or viewers can help the analysts in grouping the viewers or customer into groups based on their preferences. Either they like an action movie or fiction movie or horror movie. Let's look at one or two examples of cluster analysis as well. In a business survey that is aimed at studying what matter most to their employees, and because this will entail a lot of variables that will impact employee experience. So factor analysis has that potential of narrowing down or reduce these many variables into a fewer manageable hidden factors or variables. So understanding these hidden patterns will definitely help the management, either in hiring process or some other further analysis that may be needed by the business man. Another example is when we conduct a customer satisfactory survey, we know that there is always going to be a distinct many variables. So in relation to customer preferences for a particular product, because the customer will weigh each of these preferences, each of these items or distinct variables or attributes of the product before they will make purchase of that particular item or product. So factor analysis will help in grouping or factoring these variables. And this will enable into fewer numbers, maybe 3, maybe 4, maybe 5, just manageable one, so that it will help the management to see through the forest or to see the forest through the trees, that is, have more insights about the customer preferences for their products. We look at some methods in cluster analysis, and these methods include nearest neighbor, furthest neighbor, group average, centroid, median, and word method. And also, some method of factor analysis include principal components analysis, common factor analysis, image factoring method, D-square method, and principal axis method. Thank you for listening, and God bless you.
We want to extend our heartfelt gratitude to Professor Gafar Matanmi Oyeyemi for his enlightening presentation on this topic, uncovering hidden patterns, the importance of statistical analysis. His insights today have further highlighted crucial roles that statistics play in uncovering the hidden truths behind big data. So, as we continue on this journey under the theme effective use of statistics in making informed decision, we invite more contributions. Share your thoughts, ideas, and experiences with us. And you can reach us on the WhatsApp number I'm going to just call +44 777 874 5483. Next episode will be coming up shortly, so please stay tuned. Thank you.